Hi, let's start it. And I want to share something about page table level optimization for the ARM architectures. I'm kernel working group assignee from Huawei. I was focused on the AArch32 in recent 2 years, and I started work on this continuous page hint from Last Connect. And here I want to share the ideas and currently use it in other areas and what I could do potentially, what I could get the potentially improvement if we could set the continuous page hint in the user space. And actually, there are a lot of things we could say if we want to say the bottleneck of the system, and one of them could be the memory. And when we talk about the memory, there are different levels of management. If we talk about the page table level management, we hope that we could get fast enough page allocation and then the less fragmentations. For the latency, if we use the base page size, it could be a lot of latency when we fill into the page fold. So we use the hugetlb or transparent huge pages. The thing is, the much bigger page size we used, we potentially get the fragmentation in the systems. So we are wondering if there is a better balance between the 4K page size and the bigger page size. And so the thing is, if we think the 4K page size is too small, could we just increase into the more bigger page size? From my point of view, it's probably not a good idea because we potentially allocated more memories when we even if we need just 4K or small page size allocations. And second thing is it makes hard to interact with the I/O subsystems, which means that even if we want to load a small block to the device, we may need to operate the 64K pages in the systems. And my colleague Bamvor, who is working on the evaluation, the page size performance measurement, he focused on the performance comparison of the file systems when we migrate from 4K to the 64K pages. And he found that there is actually no overall improvement in the file systems. So the thing is, if there is no improvement for the file system, could we just do it in the anonymous pages? That's our original ideas. And before I started, I need to pick up a proper benchmark to do that. I probably not need a macro benchmark. Instead, I may need some sort of real applications benchmark, and such benchmark could be affected by the TLB miss, and it could be not. It should not be a lot of I/O operations. So we pick up spec in 2006 as our benchmark, and in my test, there is actually no overall improvement when we switch from the 4K to the 64K systems, and there are two downgradations, which is the Hammer and another is the 418.3 compared with the transparent huge pages. So if migrate to the 64K pages is not a good idea, how should we get a good balance between the small and big pages? The idea is that there is a continuous page hint in the upper attribute in the page tables in the ARM architectures. We could place the continuous bit in the 52 in the page table, which means that there will be if the page is continuous, there could be only entry 1 TLB entries when the processor loads it. It is a hint, so not all the CPU supported, but if the CPU supported, we could potentially save the TLB miss, and then we could potentially eliminate the TLB invalid broadcast, because broadcast may take a lot of times. Yeah.
When using continuous page hint, do ARM and the AArch64 cores prefetch across page boundaries? Is there any impact on cache prefetcher or cache auto prefetcher from using continuous pages?
I'm not actually know that, but it should be the same if you do not use that. If you cross the, I think the prefetcher should be within one base page, in my understanding. But I'm not sure.
That would probably be microarchitecture specific, really, wouldn't it?
Yeah.
So, again, it's not something that's on the radar that I'm aware of. It's like any CPU when you test with code, you've got the architecture and the microarchitecture. The best we can do here is get the architecture right. That's all we can really think about.
I think the hint could only be solved if we in the translation. So for the prefetch, I don't know, but maybe I could ask our IT designers. And there are different configurations in the different page size in the different levels. So you could show that if we use the continuous page hint, we could get the 2 megabytes page allocations in the 16K and the 64K base page sizes, which means that we could use the hugetlb in such systems, which is a benefit, but which is already done by the community. And here is current usage for the continuous page hint. The first one is we could allocate it. We could use as much as we can when we use the static mapping for the kernel. And second thing is we could emulate the hugetlb in the base page other than the 4K. And the end we could use page hint in the hypervisor to get to save the TLB miss. And so the question is, how should I make use it in the user space? Originally I'm thinking that could we just force the hugetlb in the mmap or bulk entry of the syscalls, which means that I do not need to imply the hugetlb in the user space. I do not need to change a lot of code. But the thing is, if I implicitly use the hugetlb in the syscall entry, the user do not know when does it use it, how many hugetlb entries will be used. So which means that it's hard to know how many entries we needed in the systems. And another idea is given that the 64K pages is smaller than the 2 megabytes, so then another idea is we should try to allocate the 64K pages after we could not use the 2 megabytes big pages. And if we want to do it in the page fault, there are actually two options. The first option is we actually maintain all the 64K, all the 16 pages all the time, and it could be complex because if user want to do some sort of unprotect or unremap or unmap, it's hard to maintain, and it could be conflict with the behavior of the applications. So my current idea is if we could allocate it when in the page fault when we really encounter the second fault in the same range and set the page hint, and we will split it when we in the unprotected or other scenarios we need to split it. And here is a performance benchmark which compare with the 4K with transparent huge page. I want to know that if I allocated more 64K pages in the 4K based systems, could I get the overall performance improvement? As you could say that if I use the hugetlb 2 megabytes, there could be a overall improvement. But the thing is, it could be lead to more fragmentation of the systems. But if I test it with 64K hugetlb in the 4K systems, there are two improvements in the 456 and 462, but there are little bit downgrade for these three cases. So the question is, if I do not use hugetlb with 64K, just do them in the page fault, could we improve the situations? So I analysis with the performance numbers with the performance counters. As you know, I use the exception taken, L2 cache access, and DTLB, ITLB load miss. From the result, we could see that if the system lead to the bigger L2 cache access in such test cases, we could show that performance is a little bit downgrade. But if not, for example, for the hammer in the second line, we could show that almost all the performance number is decreased, which in my understanding, which means that the TLB miss, the decrease of the DTLB miss, which lead to the lower exception and lower L2 cache access, which improvements the performance. So currently I'm still working on that, so there is no actually performance number I could show, but our basically idea is that it is here. Basically, I plan to allocated the continuous page in the first page fault, but I do not set the continuous page hint, and because it is after the transparent and huge TLB, it will not broke the current things in the kernel, and if we got the second fault in the page fault, which is in the same range, I will set all the PT in this range and set the continuous hint. And there are actually two things I could do. The first thing is I could do it in the I could record a pointer in the struct and then track it. Another thing is I could do it in the VMA areas. Do it in struct, which means I could save a lot of memories if there is no actually second fault in the same areas. But do it in the VMA is potentially save more TLB misses if the application access the memory is not very sequenced. And for in order to not waste too much memories, I need to free the pages if there are second faults but do not happen in the same regions. So at the end, I should split the pages in whatever I needed, such as unprotect or RRU or any scenarios. Okay. That's basically what I want to say. Thank you.
Hi, just got a few comments on the performance measurements. So with huge pages, one thing I've noticed is you can run the benchmarks and sometimes you don't see a change in performance when you take the average. But one thing you sometimes notice when you enable huge pages is the standard deviation between benchmark runs goes down with hugetlb.
Oh.
So it's varying less. And that is also a very desirable property to have, which you should look out for.
Yeah.
And this is something you'll probably find with THP, is the variation will go up because transparent huge pages are non-deterministic. So as well as the raw performance numbers, you should also think about the variation of the set. So repeat a benchmark, let's say n times for a good value of n, and then look at min, max, standard deviation, and you'll see other things that are very interesting, which will be worth exploring as well. And also with the PMU counters, when measuring TLB misses, quite a lot of CPU cores have hierarchical TLBs. So if you look at the technical reference manual, for instance, for one of the Cortex cores, they'll tell you about the level 1 TLB and the level 2 TLB. Just make sure you understand which one you're measuring. Because the L1 TLB, for instance, might not support a very big page size and will appear to have a lot of misses when in fact you're hitting in the level 2 TLB. So there's things like that to consider as well.
Okay, thanks for your comments. Okay, thank you.